reinforcement. The urgent reinforcement was completed by 2008. However, as of 2008, 60 visual aids which are needed for the reinforcement are left. So I explained the Aonoyama vessel traffic signal station, which carried out large-scale repair for seismic proof reinforcement. The Aonoyama vessel traffic signal station is a name of the facility. The mariners are familiar with the name Bisan Seto Traffic Advisory Service Center. In the Bisan Seto route, the Bisan Seto Center monitors vessel movement so as to provide sea traffic information and control shipping. The building of the Bisan Seto Center was built in 1986 for the purpose of radar site and BDS operation. It is 4 stories of the building in reinforced concrete. The seismic proof investigation of the building was carried out in 2005. The results showed that it was necessary to urgently improve the building. Because we are not able to stop the BTS on performing seismic proof improvement, we selected the seismic isolation retrofit method. The method has an advantage that the period required for the improvement is short, and there are few vibrations and noises compared with others. The seismic isolation retrofit method is superior to drastically improve safety. It consists of 4 phases. Phase 1, reinforce the existing pillars, beams, and their surroundings. Phase 2, install temporary supports and jacks. Phase 3, cut off a part of each pillar and remove. Phase 4, install the seismic isolation device in the space where a part of the pillar was removed. From 2007 to 2009, seismic proof improvement was carried out. The left side The left side is the situation that set up a temporary blaze after having removed a wall. The right side is a situation that installed reinforcing rods to strengthen a pillar. Ground is filled up at the next process. Temporary support pillars and jacks were set. Temporary support pillars and jacks. The building is supported with machine and materials. A pillar was cut off a waterless wire saw. A part of the pillar cut off was removed. Temporary support pillars and jacks were removed after the seismic isolation device was installed. This is the seismic isolation device. A seismic isolation device assumes an important role in the improvement. The device installed in the foundation for the intermediate floor of the building. The device is made of sandwiches of soft rubber seat and hard steel plates, as shown in this figure. It works as a bearing to sustain the weight of the building, and it's able to move the building laterally. Soft rubber reduces the building vibration to slow shaking, and hard steel plate contribute to sustain the weight of a building. In our country, it is predicted that a big earthquake to bring the lasting damage occurs with a high probability for the next 50 years. We must build aids to navigation which do not produce the deterioration of their function, even if a big earthquake occurs. I'm sure that the seismic proof standard contribute to the promotion of seismic proofing. I conclude my presentation. Thank you very much.
Very good. Thank you, Mr. Takahashi. So, next presenter is Dr. Terry O'Brien, Executive Director of OMC International. Dr. O'Brien is the founder and Executive Director of OMC International, which specializes in ship motion analysis, underkeel clearance, UKC, systems and channel design. He has over 40 years experience in ship motion modeling. And developed the original concept of dynamic underkeel clearance system in the early 1990s, following desk study on UKC requirements at several Australian ports. A major development during the past 4 years, and the subject of Dr. O'Brien's presentation, has been the integration of dynamic UKC technology into VTS, Navigational Assistance Services. Dr. O'Brien.
Thank you very much, Mr. Chairman. Good morning, ladies and gentlemen. The topic may be the heading Centralised Underkeel Clearance Management is not meant to in any way to imply that we're promoting remote pilotage. As the keynote speaker mentioned, that was something that was in vogue a few years ago, but by centralised underkeel clearance management, we are really talking about gathering together all the real-time environmental data and forecasting of that data changes and all the calculations that are required to ensure safe underkeel clearances during ship passages through restricted channels, and then the distribution of that information to the users who need it at the time they need it, including pilots on board vessels and VTS centres monitoring the safety of those vessel transits. Just a brief word about our company. Our core business has been the research, development, installation and 24/7 support of UKC management systems during the last 17 years. And we have a stand at 34 at the back of the hall. If you can get past all the flashing lights to a very quiet part of the hall down there, we'll be very happy to go through some of the technical aspects which I won't have time to cover in this presentation. Just a brief timeline to show the history, if you like, of the development of the technology and the applications. The development has been very much driven by the applications and by the feedback which we've received from those applications from harbour masters, pilots, port users. Since the first installation in 1993 at Hay Point on the northeastern coast of Australia, a coal export terminal,